Hello everyone, welcome to the session. So this is the last problem that I want to discuss here using the substitution method. And maybe after solving these three problems, you will get an intuitive idea that how basically we can solve any recurrence relation using a substitution method. Okay, so let's get started with the today's session. Here again, we are having a recurrence relation which says that the value of t of n is something which is equals to 1 when the value of n is equals to 1, and the value of n is greater than 1 when the value is, or the recurrence relation is t of n by 2 plus n. So this is a kind of a recurrence relation that we have. Now again, this recurrence relation we need to solve using a substitution method. Now I am expecting everyone to please pause this video as of now, take this question and try to solve it on your own, and do let me know that what answer you are getting. Okay, because I think now the approach, the way we used to solve any recurrence relation using a substitution method is already conveyed in the above two videos, right? So the same method, same thing you need to do. It's just that instead of substituting that n minus 1 or n minus 2, here we need to substitute the value of t of n by 2. So let's get started. I hope that everyone already have tried it once. So t of n is something which is equals to t of n by 2 plus the value of n. Now what we can do is that we can try to solve the value for t of n by 2. It is something which is equals to t of n by 2 to the power 2 plus n by 2. What I am doing is that by seeing the above pattern, I am just trying to what I can say substitute the value for t of n by 2. Now it means that what I am getting as t of n, which is equals to t of n by 2 to the power 2 plus n by 2 plus the value of n. That's what we are getting when we are trying to substitute here for the two times. First time we are having this equation, right? This is for the first time. Second time we are getting this kind of equation. Okay, this is for the second time. Now for the third time, what will happen is that we will be able to get, now we need to substitute this value t of n by 2 to the power 2. So here basically what will happen is that it's 4, right? Now we need to divide it again by 2 in order to do the substitution. So it is nothing but is equals to t of n by 2 to the power 3 plus something which we are getting as n by 2 to the power 2 plus n by 2 plus the value of n. This is something which we are getting for the third time. Now again the same question I can ask from you, that how many times do we divide this value of 2, right, again and again? It means that at what point of time this n by 2 to the power k is equals to 1, because 1 is something which is the base case condition in our question. This is something which is a, I can say, base case condition, right? If this is the base case condition, so this is what we can write here. Now here if you will see, n is something which is equals to 2 to the power k, so the value of k is something which is equals to log of n base 2. This is something which we are getting. Okay, fine. So here the value of t of n is something which is equals to, it means that we need to repeat this same experiment log of n base 2 times, right? So here t of n by 2 to the power k plus, by seeing just the above pattern, I am getting a sense that it should be t to the n by 2 to the power k minus 1, right? Plus n by 2 to the power k minus 2 until so on, and we are getting at a very end the result is n by 2 plus n. Here we can just try to replace this value of k with the value which is log of n base 2, which we have already evaluated. So here the value of t of n is something which is equals to t of n by 2 to the power log of n base 2 plus n by 2 to the power log of n base 2 minus 1 plus n by 2 to the power log of n base 2 minus 2 until so on plus n by 2 plus n. Now here if you will see, what we can do is that we will be able to get the value as t of 1 plus, here what we can get is we can take the value of n as common, and here again we are getting something called as 1 divided by, again, see why we are getting this one. Let me try to first of all, I think maybe maximum students will not able to get an idea how I am writing this. So this n and 2 can be interchanged with each other. So here what we will be able to get is n log of 2 base 2, and when the base and the coefficient that we have here is same, the value will be equals to 1. That's why we are getting the value as n. That's why we are getting the value as n here. So n divided by n is something which is equals to 1 here. Now what we can do is that we can write the same thing in this format. 1 by 2 to the power 0 plus 1 by 2 to the power 1 until so on, divided by 1 by 2 log of n base 2 minus 1. Minus 1. How we are getting this? What we have did here is that we have tried to just take the constants, focus on this part in the reverse order. So what I did is that I tried to take the constants in a reverse order. So it's n plus n by 2 plus n by 2 to the power 2 until so on, until n by 2 to the power log of n base 2 minus 1. So what I did is that I just took the n as coefficient. When we take the n as coefficient, it will be 1 by 2 to the power 0, 1 by 2 to the power 1, 1 by 2 to the power 2, until what value? Log of n base 2 minus 1. Can I write like this? I hope this is making sense, right? So basically this value will become t of 1, and this particular portion that I am writing here, we have written in the form of a reverse order. We have written in the form of a reverse order. So that I want to show you here something. Here if you will observe, this is something which we called as a GP series, where the common ratio R value is 1 by 2. How we calculate the common ratio? It is nothing but 1 by 2 to the power 1 divided by 1 by 2 to the power 0, right? So here common ratio is 1 by 2. Now this is a sum of GP series where the value of R is less than 1. Now if you refer your I think 9th, 10th or 11th, 12th classes, here we have understood that the sum of GP series when the value of R is less than 1 is something which is equals to A into 1 minus R to the power n divided by 1 minus R. This is the sum of a GP series that we have. Now here if you will see, what is the value of A? A is something which is the first value which we have in our series, which is nothing but 1 here, because A is nothing but 1 by 2 to the power 0, which is something which is equals to 1 here. Now what we can do is that t of 1 we already know is equals to 1 only. It's a constant term. So 1 plus, what is the value of A? It is 1 into 1 minus 1 by 2 to the power n. Here if you will see, what is the value of n that we have? How many number of terms that we have? Approximately equals to log of n base 2. Can we write like this? Log of n base 2 divided by 1 minus 1 by 2. Here if you will try to solve this equation, this GP series equation, for sure if you will see here, and obviously outside this there is a n term which is already in a multiplication term. Now here if you will try to solve this particular series, you will be getting a constant value. So here what I am saying is that 1 plus any constant, suppose which I am representing as 1 only, into n is something where we need to take the higher factor in order to calculate the big O time complexity. So this is something which we are getting as a big O of n. So if you will try to see here, what we have did so far is that in any of the substitution method, whenever any problem is provided to you, the first step that you have to do is that you have to look for a recursive term. That what is the recursive term which is present inside my recurrence relation, right? There is always some recursive term. That's why there is the recurrence relation. Now what you have to do is that you need to substitute that recursive term again and again. But after just you have to see the pattern here. By seeing or looking into the pattern, you will be able to get the substitution value. But now you have the major objective here is to find out that what is the value of k. This is very important to find out, because until what point of time do I suppose to substitute in a substitution method? This is what you will be able to get when you know the base case criteria or base case condition. That what is the point where it is terminating? What is the point where I should write this value as 1? Because I know when the value of n is 1, the value will be equals to 1 here. So that's why we took like this as a base case condition. Now with the help of these values, you will be able to somehow get the value of k, and until that point of time, you need to write the values. Now you always get somewhere or the other in a substitution method a series, which is somewhere a mathematical series you will be able to get. Whether it is a AP series, GP series, or any logarithmic series or exponential series, or maybe sine, cos, or maybe sum of n natural numbers. So these things you should know. These are the very basic things. So basic, I am saying, series you should be aware of. Once you will get an idea about that, you will be always having that higher term. You need to see the higher I would say exponent term, or higher term, higher degree, right? So here you need to see that, and whatever you are getting here will be your final time complexity that you will be able to get here, right? That is the simple approach to solve any recurrence relation with the help of a substitution method. And that is what I think I have conveyed with the past 3 videos which I have created here, so that you will be able to get a clear-cut idea that how basically the substitution method will work. Now in the next upcoming video, what I will talk about is that how basically the recurrence relation can be solved using a recursive tree approach, and when basically we should go for that particular method instead of going for a substitution method. Till then, bye-bye everyone, stay tuned, and I hope that you all are excited to watch that particular video as well, where now we will talk about some another method. So with this, happy learning to all, bye-bye everyone, see you soon in the next upcoming video.